So in this situation, we want to react a weak acid and a weak base together. So let's do that. Let's take acetic acid, the weak acid. There's the equilibrium expression for that dissociation. That has a Ka. I'm going to react that with the weak base. Now, I've written this kind of artificially here. I've said the weak base is going to react with the weak acid, but I've had the weak base reacting with the H3O pluses in solution. So what I'm doing is I'm saying, let's go to an artificial spot. Let's say HAC reacts to form AC minus, and let's say it goes all the way. Now, it doesn't do that, but we know for equilibria, we can get to any starting point we want and then apply the equilibrium expression. Equilibrium will be attained from wherever I go. And of course, I do that anyway. If I were going to just calculate this one, I would say, let's start with it all here and apply the equilibrium. I can do it from the other direction. Let's start with it all here and apply the equilibrium. So if I start with it all here, I say, well, then add the base, and the base reacts with H3O plus. The base reacts with H3O plus, forms NH4 plus and water. So the artificial situation, I'm 100% this. I add some of that, reacts and goes in this direction. This equilibrium is the K for NH4 plus. That's the conjugate acid of NH3. So I can put the conjugate acid expression here, and I can get this K because Ka's times Kb's are 10 to the minus 14. So even if I wasn't given this, I was given the Kb, I could still say, well, this Ka is equal to Kw over Kb for this base, because Ka times Kb has to be Kw. So I can get this number from Kb if that's what I have. And in this case, that is what I had. So this Ka was 10 to the minus 4.75. This Kb was 10 to the minus 4.75. They just happen to be numerically equal. So this Ka is Kw, 10 to the minus 14, over 10 to the minus 4.75. Kw over Kb is the conjugate acid equilibrium constant. So I have K for this reaction going either direction. I've got a K. This in either direction. So this conjugate acid expression I have. But what I want, I'm going to start in those conditions. What I want is to reverse this one, because what I want is the reaction of the acid, weak acid with the weak base. So I just reversed this, and that's convenient. You'll notice it's convenient because if I do that, then that cancels with that, and that cancels with that, and that's what we were saying. We were saying our starting point is every H3O plus reacts with an NH3 minus and forms NH4 plus and AC. Where does the equilibrium go from there? Well, the equilibrium goes from there. We can write it down. So let's get rid of some of these annotations here. So this reaction is 1 over the Ka for NH4 plus. I reversed that, so I took 1 over the equilibrium constant for the Ka reaction. I'm going to add those two. So when I add those two together, I get the reaction I'm interested in, HAC plus NH3 goes to NH4 plus AC minus. That is the weak acid with the weak base. I can get the K for that. The sum of those two is the product of those two. So the K for that reaction is Ka1 for HAC, Ka2, that weak acid, and that K is 1.8 times 10 to the minus 5. That is, I was saying here, it was 10 to the minus 4.75. 10 to the minus 4.75 is 1.8 times 10 to the minus 5. That decimal translates into this integer exponent. And the same thing here, I've taken the 1 over Ka2 to get that equilibrium constant. So those two form the K for this, and that is about 10 to the minus 5 over 10 to the minus 10 is about 10 to the plus 5. These two numbers don't matter very much because it's 10 to the plus 5. So it's huge. That means this K goes all the way, large K, to this side, and I have 100% ions in solution at the end of that reaction. Weak acid with weak base.